The William W. Hay Railroad Seminar Series is sponsored by the Rail Transportation and Engineering Center here at the University of Illinois at Urbana-Champaign. On behalf of all of us, we thank the AAR, BNSF, CN, Hanson Professional Services, and Union Pacific for their ongoing support of RailTech. It's greatly appreciated by those of us here on campus, as well as those participating via the internet. I want to welcome the more than 170 people who've registered for this seminar. They hail from 12 different countries on 4 different continents, so it's truly an international audience today. The list of attendees includes freight and passenger railroads, transit organizations, federal and state DOTs, engineering firms, universities, research organizations, including a number of our friends from AAR and TTCI, so I want to particularly welcome them. Technology developers and suppliers and others. We're very pleased that you could all join us today. Those of you who wish to receive PDHs for your participation, please see the instructions in the seminar announcement that you should have received or on our website. One of the remarkable success stories of North American freight railroads over the past half-century is their dramatic improvements in productivity. This transformation was no accident, but rather resulted from a series of engineering and operational changes driven by marketplace factors, and in many cases informed by research conducted by the railroads, AAR, the railway supply industry, and our speaker today, among others. The result is arguably the most efficient freight rail system in the world, providing both economic and environmental benefits to residents of this continent. Our speaker today is exceptionally well qualified to discuss this subject. Mr. Carl Martland has had a long and successful career in academia, working closely with the rail industry on many of the analyses that helped him evaluate the various decisions they needed to continue improving their engineering and operational practices. He completed his BS in mathematics at MIT in 1968 and his MS in civil engineering also at MIT in 1972. Following graduation, he stayed on at MIT, working in increasingly senior research and teaching positions in transportation with a particular focus on rail transport. He supervised research on track maintenance planning, life cycle costing, service design, costing and control, equipment utilization, preventive maintenance, terminal operations, intermodal transportation, productivity, and technology assessment. Beginning in 1983, he managed the AAR-affiliated lab at MIT, a role I later took on here at Illinois when I moved here in 1998. One of the most productive aspects, pun intended, of the AAR program that he directed at MIT were the aforementioned studies that he conducted for the railroads during their march towards ever-increasing productivity. As a teacher, he taught undergraduate and graduate classes, including freight transportation management, project evaluation, engineering system design, and transportation demand and economics. Mr. Martland is a past president of the Transportation Research Forum, and he served on committees of ARIMA and the Transportation Research Board as well. He's written extensively on freight transportation, publishing more than 120 papers and research reports, and his papers have earned many awards. And in 1997, the Transportation Research Forum selected Mr. Martland as the recipient of the Distinguished Transportation Research Award for his lifetime contributions to rail systems research. I'm very pleased to introduce Mr. Carl Martland, who will present his seminar entitled A Half-Century of Productivity Improvements in the U.S. Rail Freight Industry from 1960 to 2010.
Thank you, Chris. I'm wondering about the lights. Can we dim the lights at least in the front? Yeah, that's good. So I'm here to talk about productivity. And I believe I attended a conference on railroad productivity somewhere within a couple hundred yards of this location back around 1981 or 82. So I think that was my first visit to this university. What I'm showing here is, if you just absorb the 5 things I'm showing here, you will understand what I'm talking about today. Start out, track structure. Track structure today is much different than it was in 1960. Better components, lasts longer, better maintenance, better inspection. Because you have better track structure, you can run Heavier trains, that's showing the 286,000 pound gross vehicle weight limit, which went in about 1990 and went viral, I guess you would say, after that. That's number 2. Number 3, we'll look at locomotives, more powerful locomotives. I guess 3.5 is this multi-level car behind there, which is specialized equipment well suited for transporting something on rail rather than a truck. Over here we have a double stack train. These came in during the 1980s. Tremendous technological innovation, which we all learned as kids when you put one block on top of another and you realized you could have twice as many. Of course, you had to fix the bridges before you could do it. And number 5, 1, 2, 3, 4. Number 5 is information technology that allows me to be standing here talking to 170 people, well, 150 people in 12 countries, plus the elite group right here in front of me. Okay, basically, the main things that helped rationalize the system from 1960 to 2010, what's really going on is you started out with a system built in the 19th century, laid out in the 19th century, that was being transformed into something suitable for today. So you had to have network rationalization, abandonment of branch lines, consolidation of main lines, consolidation of terminals, merges, all that stuff. Second, you've got regulatory change that allowed pricing freedom, contract rates. Big area, technological improvements for both track and equipment, IT, and also labor agreements. So we'll talk a little bit about each of these. Oh, the photograph here, this is showing competition a little more than 100 years ago, where you still have some carts that are horse-drawn, with the horse knew where to stop for each of the pickup and set-off points for freight, and you have a very early truck here. And today, obviously, the competition is much different. Now, one way to look at productivity is labor productivity. How much work do you get out of anybody? And Paul Banner was a railroad economist, and he said, well, let's relate each class of employees to some service unit. What's a service unit? The service unit was used by the ICC in costing. So you had things like maintenance of way expenses would be related to revenue ton miles, or maintenance of equipment could be related to car miles. Train and engine men expense relate to train miles or car loads. So car loads, train miles, ton miles, those are service units. And this shows employees per unit of output. 1968, something like 400 administrators and down to maybe 250 train and engine men for related to car loads and train miles. And you can just see this tremendous reduction in the employees required. Okay, but that's not looking at capital. Shouldn't it be looking at other things? Well, here's another look at it. We've got revenue ton miles, which is going up over this period, almost doubling. Track miles cut close to in half, abandonment of branch lines. Employees way down, and freight cars generally declining, but then coming up again by 2008. So yeah, output's gone way up, however you measure it, and all the resources are way down. And eventually, financial performance improved. I'll show some more details on this as we go on, but NROI is net railway operating income. That's looking at sort of the excess of revenue versus standard costs without looking at the the debt payments and things like that. So that went down between 66 and 80. 66, close to a 4% return on investment was pretty good then, because that was what you could borrow money at. You could borrow money at 4% and borrow money for freight cars, maybe a little less. So that went up to 10% by 2008. And return on equity, all those stock traders and whatnot, they're interested in this, way, way up. Of course, what you often don't hear is you have to relate these numbers, the return on investment and return on equity, to the cost of capital. And the ICC measured the cost of capital. This is a weighted average of the cost of interest on the bonds and the implied return on equity that's required to sell stock. And it wasn't until 2008, this green column here, that the return on equity and return on investment actually came close to or exceeded the regulatory cost of capital. So yes, financial performance improved, but it took a while. Now, another thing changed over this long period, which is the traffic. And I've got three colors here. From 1969 to 2008, the average load increased. So we'll say that's about 20, 25% more freight in each type of car. So in the middle, we see farm products, 2 million plus carloads in 69, 1.7 million in 2008. That's a decrease of 20%. But since there's more freight in each car, that's actually about the same. Of course, a few more people in 2008 and 1969, so you might suspect that some of that food is moving by truck that used to move by rail. Whoops. I'm going not backwards. This is just going forward. How do I get back to where it was? The hard way? I promise, I'll try to be more careful. Okay, so the green are three commodities where the railroads have more traffic, much more traffic today than they did 40 or 50 years ago. And you look at coal, chemicals, and motor vehicles. They're commodities that move in very high volumes. And for chemicals and motor vehicles, you need highly specialized equipment. So it's really well suited to rail. The bottom tier is products that used to move in boxcars or general purpose cars by and large, and that traffic has fallen off. And that's because we have an interstate highway system and trucks. So I'm going to break this into several sections because at several points in the last 40 years, I've done papers on productivity, the causes, and the major factors helping and hurting. So let's start out looking at in the 60s. You had a low inflation rate, 1.6%. Now, that may not seem like a lot to those of you under the age of 30, since for the past 10 years, inflation has been very modest. And now people are getting upset. It might be 2% or 3% or 5%. 1980, it was probably 10%. So inflation was low. Income, return on investment was pretty good. The two big railroads, the New York Central and the Pennsylvania Railroad. The Pennsylvania Railroad viewed itself as the #1 railroad in the world. They were going to merge and solve all kinds of problems. Everybody thought it would be great. And the railroads in the late 50s had said, you know, we don't need 5 or 6 people to operate a freight train anymore. We don't have steam engines. The so-called fireman is gone. Why do we need them? Well, the fireman was a training ground to be an engineer, and you might have 2 or 3 brakemen. And because you're going in and out of these little sidings and dropping off a few cars here and a few cars there. But as you move into unit trains, you don't need all those people. So the railroad said, damn it, we don't need it. And what did the unions do? Said, sorry, we've got an agreement. You do have to have them and pay us. And if you don't, if you try to do this stuff, we'll go on strike. So there's a general strike. Railroad shut down. The federal government says you have to call off the strike. You can't threaten the economy with a strike. The union said, we're not that stupid. We'll then shut down one railroad at a time. And they had all kinds of strife during the 60s. That story will be continued. The railroads were investing in hump yards, which that could be a false hope, or it's a good sign that they're investing in the ability to classify general purpose freight. But it's also a lot of investment that was going to be not necessarily needed in the 1990s or 2000s. Okay, so the problems, the fundamental problem was the network was overbuilt. And that crew consist issue and the basis of pay, a crew is paid for 100 miles. If they went 200 miles in one day, you get paid double. So that was kind of a tough thing. If you got a train that could actually average 50 miles an hour, you could easily go 200 miles in a day. Inflation is coming. You've got competition both for passenger and freight. You've got problems on pricing. The railroads wanted to have contract rates, say, or raise price or low to compete more effectively. The unit trains of heavier cars started coming in, and the track structure wasn't ready. And network rationalization was needed, but it took a long time. So what happens? June 21st, 1970, the Penn Central Railroad, the darling of Wall Street, the railroad that was supposed to solve all the problems, went bankrupt. And this was a major issue, not just for railroads, but for any large company that's shipping automobiles, grain, what have you. And it was the same time, several small Northeastern railroads went bankrupt. So almost the entire Northeast was bankrupt. And it looked like the whole system could just fall apart. Now, why did this happen? Penn Central said, labor strife, light density lines, passenger operations, and too much track. What did the feds do? A lot happened in the 70s. So they created the Amtrak that deals with the passenger problem. Second, the 3R Act, Regional Railroad Revitalization, created a group called the U.S. Railway Association. And they did a lot of studies that resulted in the creation of Conrail, which formed from the Penn Central, and most of the other bankrupt railroads formed into one big railroad. That happened in 1976, and the federal government invested about a lot of money into upgrading that railroad, which basically went Chicago, St. Louis, over to Washington, D.C., up into New England. Then a couple of years later, the Railroad Revitalization and Regulatory Reform, 99% of the time we call that the 4R Act, began to ease regulations, both for abandonments and merges, as well as for pricing. So lots of studies done in the late 70s. I mentioned at the bottom there the freight car utilization program, because that's what actually got me not started in, but firmly entrenched in railroad research for close to 40 years. That was a joint program, funding from the Federal Railroad Administration. The railroads contributed manpower to a series of task forces. The AAR contributed manpower from its research and test department. And this was a program that went on for about 10 years. And it looked at all kinds of system issues and ways to manage the railroads better. But while this is going on, things get worse. So this is the Yearbook of Railroad Facts. It's a nice booklet that came out every year, a lot of basic facts about ton miles, car miles, loads, equipment, whatever. And it would always have an introductory section, which kind of can be used as a view as to what railroad managers thought. This came from the AAR. So it's saying inflation is bad, it's worsening, traffic is dropping off, piggyback traffic is declining, and piggyback is a trailer on a flat car. Nothing like double stack container trains, it's just a trailer on a flat car. And the federal government had allowed increased length and weight for trucks, which are now operating over the interstate, so that competition was really bad. So March 17th, 1975, the Rock Island declares bankruptcy. And I'm showing here a picture of a grain terminal, because the problem with the Midwestern railroads is that they were laid out in the 19th century when to move anything from a farm to a railroad or a business of some kind of town, you did it by, horse and buggy or wagon. And the cost of that in 1850, I just read this yesterday, it was 15 cents a ton mile. Now, what does that mean? Well, a truck going down the highway today might cost 5 or 6 cents a ton mile. So it's 15 cents in $1850, so you basically built branch lines that covered the entire Midwest so that every farm was within 15 or 25 miles of a railroad. And what you really wanted to have later on is a nice large grain elevator right next to a nice well-run railroad. So what are the feds going to do? There's a lot of talk of farm rail. Well, is that what we want to do? Maybe you just let them fail. And that's what happened to the Rock Island. They just let it go out of business. And what happened? They broke it up into pieces and said, let's sell it off, see if we can sell it. Just like you're moving out of your house, sell what you can't take with you. Do you create another Conrail in the Midwest? Or do you deregulate? And people did not want to spend, Congress did not want to spend a lot of money like they had with Conrail. And they didn't want to take over the railroad industry. So they said, what can we do? And there's a large number of studies. I've got a shelf about that thick with the actual studies, but the best one to read is a prospectus for change in the freight rail industry. And that basically came out in 1978. It said, basically, if we continue, this ship is going down. That there'll be enormous capital shortages. The rail industry is only going to be left competing for, coal and low-value goods. They won't be able to operate safely, and they'll probably be under the control of public agencies unless you do something. So what was the something? Deregulation. That was the clarion call in the late 70s. Deregulate. Ted Kennedy and the liberal factions of Congress loved it, and the conservative faction of Congress loved it. And labor loved it as long as there were protections for labor. Everybody loved it. This was going to save the industry. So it expanded the deregulation of rates and rate flexibility, which had started earlier under the 4R Act, and probably, also affected the procedures by which you could abandon lines. And abandonment was something that up until about 1975 or 76, the railroad said, we've only got 3 cars a month here, we should abandon the line. And somebody from the customer said, well, we might have something in the future. And the town would say, we have to have this line. And the great fights. And the resolution turned out to be fairly straightforward. If you guys want the line, money, $500,000 a year. You want your line? Your long one, I need $1 million, And so, and then the legislation gave the states money so they could actually pay the railroads to keep the lines open for a while. And eventually even they realized that sometimes it took 20 years that you really didn't need as many lines. So my first study of productivity led to a paper called Prices, Productivity and Profitability in the Rail Industry. And it came out with at a summary, this chart here, where the green line is productivity, which is basically constant from 73 to 83. These two lines, which are sort of right on top of each other, that's a measure of output in blue and a measure of input in the orange. And they're basically moving together. And the reason is that for the most part, until 1980, there was a rate increase every year. Now, Penn Central has said delayed rate increases is a problem that they failed. ICC is terrible. They won't let us raise the rates. We're going to go bankrupt. And we did go bankrupt, and that's why. Well, they couldn't lower their rates either. And the truckers couldn't lower their rates. So you had a period of regulation there where the rates kept pace with cost. And the fact that that's declining is because the traffic took this sharp drop after the passage of the Staggers Act, because the railroads were able to raise the rates on those boxcars on the branch lines and any traffic that they really didn't want. And so there was a sharp decline in traffic. The biggest reasons, and I'm assuming that nobody is really interested in exactly how I calculated productivity, prices, and all this stuff. It's in the papers if you want to read it. But we know that productivity over the 50 years improved a lot, and over this 10-year period, it was about stable. In this period, you had the shift from the traditional carload, and you're getting more intermodal and more unit trains. Labor productivity, I've shown some of that, was getting better. By the end of this, you had crew consist agreements with almost all the railroads and unions, so you are operating a lot of trains with 3 people rather than 4 or 5, or in some cases 6 back in the 60s. There's fewer light density lines. Any of you like to ride on a bike along the rail trails? That's what we're talking about. They used to be the branch lines. The railroads had raised prices where they didn't really care about the traffic. And the caboose. I show a B&M caboose because I did a lot of work on the service planning with the Boston and Maine as a test case. But the caboose, one reason for the caboose was that the 2 guys in the caboose could look out the window and they would know if they were still attached to the train. So you put an electronic device at the end of the train that says, sends out a signal, I'm here, I'm here, I'm here. So the engineer knows that the caboose is there, so you don't need that. And if you have, if you're not doing a lot of switching, you don't need someone at the back of the train to do as much work. And plus you have radio, so you give a radio to the brakeman. So if you do need to do work, you can drop somebody off here, then move the train along, and then he can be at the back and you're at the front and you can coordinate. So, but the net effect in that period was modest. And I don't know if Gerard McCullough is on the line. He might be, but he and I worked on productivity back close to 40 years ago. And our conclusion was that, no decline in productivity. That's pretty amazing since you're cutting the volume. And everybody thought that railroads were a high fixed cost industry. So if you cut volume, you really should be cutting into your profits. But the railroads were able to cut capacity as well as to keep in line with the decline in traffic. Now, 2 big major changes during the 70s. One We've got containerization, international trade, double stack containers. All this led to, this is showing a container ship going through the Panama Canal. And the Panama Canal was getting congested. And there's an option with all this stuff coming from, at that time, Japan or Korea or Taiwan. You could bring the containers into the West Coast in Canada, in Seattle or Oregon or LA Long Beach. And you could put it onto a train and take it into Chicago and wherever it's going to be going. So you've got containerization, globalization, and then you've got coal from the Powder River Basin. Why? Low sulfur coal. The Clean Air Act required reduction in emissions, and BN and other railroads figured out you could have heavier cars hauling unit trains of coal, and it's really cheap. Oops. Also, you're getting the technological change. Here's another picture of a sharp curve, which has concrete ties, an innovation. They last longer and withstand the heavier loads. You've got equipment that can detect defects in the rail. So if you find a defect internally, you can cut out a little piece of rail, put in another plug, and you're not going to find the broken rails when the train derails and you look under it and say, oh my, the rail broke. So that's one innovation. I mentioned the double stack container train, simple innovation. And especially in the West, where there weren't many bridges, it was pretty easy to implement in the heavy haul car. You put that together for coal. In 1966, you're going there with, 170-ton cars. Now, the 70-ton refers to 70 tons of coal in a car. But by 2008, you're up to using a so-called steel aluminum car. In each steel aluminum car, there's a slight typo here, has 120 tons of coal, not 20 tons of coal. And you put 130 of those together and you end up with 15,000 tons, double what you had in 1966. Now you needed, some cases, you have to have sidings a little bit longer, but these innovations came about to a large extent because of research out at the Fast Track in Pueblo, a research facility funded by the federal government and operated by the Association of American Railroads, and basically tested all kinds of things. And the kinds of tests they did there are still being done today, about 10 miles away in the Civil Engineering Rail Tech Lab. For the globalization and containerization, you had to do something other than the piggyback operation from the 60s. This is showing, it's not the greatest photograph, but this is showing someone has built a ramp using a bunch of old ties and throw a little gravel on it. And you back up a string of 8 or 10 89-foot flat cars to that ramp. Then you get a bunch of truck drivers willing to back up over several hundred feet, positioning a trailer. You have to start way at the end and then filling up those flat cars with trailers. And then someone gets a couple of the locomotives together and they attach all those strings of freight cars and off they go. Well, that's 1965. This is somewhere about 1985. The first idea was to put 2 containers on a railroad car. And they started with pretty heavy cars with big ends at each end to protect the ends of the containers. And this is kind of what they went to. They said, well, containers aren't that heavy. If you use this kind of car that has 2 trailers on the container, what you have basically is a 90-foot long bridge. And if there are civil engineers in here, you realize you need a pretty big piece of iron across the middle of that so that the thing doesn't collapse. But if you're going to stack them one on top of the other, you don't have that as much need for structural integrity. And at the bottom, it doesn't matter if there are holes there because you're going to stack them one on the other. Okay, so let's leap forward now up to 1996. After we had the container revolution, you've had the coal, and more productivity gains. But now we see that the rail freight rates have fallen. The freight rates have fallen sharply from where they were before Staggers. And by today, 1996, nearly 70% of the freight was moving under contract rates. So it's big shippers, big rail, moving big loads in big cars. So from 65 to 95, this is combining the two different studies. We started out, this is what we saw before, from 73 to 83, declining output, rising prices. Before that, it had kind of been stable output with prices rising because of the general rate increases. Penn Central complained that they were too slow, but they were there. It happened every year. For 80, so in here we get Staggers Act, 1980, and you get a sharp increase as they raise the rates on those branch line traffic, but from 83 to 95, the prices are declining. And this is a price index, the Bureau of Labor Statistics or the Surface Transportation Board later on would produce price indices that related to the actual mix of traffic. So prices are going down. But 1995, still reasons to be excited. The financial performance was the best since World War II. As I pointed out earlier, it still wasn't reaching the cost of capital, regulatory cost of capital, but it was a lot better. And they had the mega mergers that gave us CSX and BNSF. In the Northeast, Conrail was broken up and split between Norfolk Southern and CSX. And you have the UP that picked up the Missouri Pacific and other railroads out in the West. So you had consolidation. I guess the further consolidation in the East in 1995 was the split up of Conrail. So the research had paid off. Heavier cars could operate on better track, and the globalization of trade meant, rapid growth in both coal and containers. The problems, one that you don't hear much about, is that the price competition was fierce, and it hurt the railroads somewhat. The group that really got hurt were truck drivers. And you may hear recently, we've got the supply chain problem and there aren't enough truck drivers. Well, the Teamster truck driver in 1975, 78 era was making probably $30,000, $35,000 a year. The owner-operator truck driver, a lot of moving the long-haul freight on the highways by 1995 and through to another 10 years, was probably making $30,000. So the truck drivers in 2000 were making probably a little less money than their parents were making in 1980. And then if you adjust for inflation, they're making a lot less. The reason you don't have enough truck drivers is the pay for being a truck driver is not that great. Okay. Research. When Chris and I and others started doing railroad research, there was a lot of money for research into rail systems and rail technology, information technology, all kinds of things. And that had been cut back over the years. And there was some of the sources of productivity were being exhausted. I mean, you can only abandon so much. Eventually you need to have track. So let's look from 1980 to 2006. And it's not just coal trains, but this is looking at the average, I'm not going to press another button. The average gross vehicle weight for general merchandise went up on the order of 50%. So for coal, it went up because we have more coal in each car, but the percentage increase for general freight was even larger because you had going from a 40-foot boxcar to a 50-foot boxcar that's another foot or two higher, and you can put more stuff in it. So revenue per ton was up a little bit, but part of that reflects intermodal. Intermodal is not heavy, so you have, you're getting a good price per ton for intermodal. The revenue per carload was down, even though the average carload was probably 20% heavier. Revenue per ton mile in current dollars was a little bit down, and in constant dollars was down quite a bit. And overall traffic up, rates were down. As I showed in that earlier slide, it varied a lot by commodity. If you had some areas like coal, chemicals, motor vehicles, you had lower prices and much higher volume. The bottom, the traditional boxcar or general purpose type stuff, the prices were up, the volume was down. And in the middle, you had kind of a mix, kind of stable revenue and modest growth, usually. That picture is showing a vehicle unloading ramp down in Baltimore where you've got the so-called multi-level cars, just a frame you stick on top of a flat car, and you go to a General Motors plant or somebody, and they got a team of drivers. They drive the cars in one after the other and pack them in, and then you go to a unloading point and you drive them out. At one point, cars were shipped in boxcars, if you can imagine how you might do that. You need some modification, and it's very cumbersome. Okay, this again is another study of rates showing in general the decline in rates. So in 1985, this is showing the rates in in constant dollars. So it's probably constant dollars around 2007. So the rates had dropped for 20 years and then started to come up in 2007, whether you're looking at the short haul, medium haul, or long haul freight. And it's important to look at those three separately because there was a lot more short haul freight back in 85 or 65 than in 2007. The average haul was getting up close to probably 600 or 700, 800 miles. From 2003 to 2007, rates actually went up. And that was the one period where the economists look at this, say, the railroads actually had some pricing power then. Why? Well, it's because the price of gasoline went from $1 or $2 per gallon to $4, diesel fuel, up to $4 a gallon. And if you're going getting 5 miles per gallon in one of those trucks going on the interstate highway, if you get to $5 a gallon, that's $1 a mile for fuel. Plus you got to pay for the equipment, plus you have to pay the driver a little bit. So that was a period where intermodal really picked up. So now I'm looking at 85 to 2007, and again, the graph is the same. It's productivity going way up because output is going up, input is going down, and it doesn't matter that much. Well, it matters. Well, this is the ratio of price increases to cost increases. So this is showing that for this entire period, prices until the end were going down relative to the cost index. What does that mean? Prices are going down relative to costs, and you got all these tremendous productivity improvements. What's happened to all the benefits? Well, the benefits have gone to the shippers. That's taking the actual reduction in rates, relating that to the total volume that was shipped, and you come up with big numbers. These are billions. So 25 billion in 2005 to the shippers, and 3 or 4 billion to the railroads. So big change. This is the net railway operating income over that same period. And it's the blue line is the constant dollar set in 1990. And it's showing, well, yeah, the financial improvement was real, but it's not really that exorbitant. So what are railroad facts? So what's the AAR position in 2007? Better output per employee, more efficient utilization of infrastructure, fuel efficiency, helped freight railroads attain their best operating ratio since World War II. Resulting financial performance was a welcome and long-sought improvement after a disappointing record over the last 40 years, okay? A disappointing record of financial performance over the last 40 years. Not from 1960 to 1980 until the Staggers Act was passed and everything was wonderful. Over the last 40 years, from 1967, we'll call that 2006. Disappointing record over the last 40 years. Okay. What else was going on in 2007? You had high fuel prices. The railroads had they'd finally started to invest in capacity. I show this chart right here. This is refueling locomotives at the UP's terminal in North Platte. That's where the unit coal trains come out of the Powder River Basin. Back then, there were 50 per day. Train comes in. They needed more locomotives in the west than in the east, so they had to adjust the consist of locomotives. They had to fuel the locomotives, and the trains were coming in at a rate of 2 per hour. So they had to have holding tracks so they could make everything work. And they invested what was needed to increase capacity. And in 2007, they have public officials really supporting railroads, both freight and passenger, and they're starting to do public-private partnerships to do things like in St. Louis, they built a 2-mile-long bridge, elevated structure for the freight railroads to cross without interfering with the local traffic. And it was a expensive project, but had major benefits in terms of lower congestion for both railroads and for the public. Problems, a lot of talk about re-regulation because customers were ticked off when the rates they thought were going up high. And it's kind of weird because in real terms, some of the so-called high rates were actually lower than they were back in 1975 or 1980. People wanted passenger service without understanding that running a high-speed train on an old freight line doesn't make any sense because the curves are a little bit too sharp. And there's too many trains there already. There's concerns about positive train control and safety. And would the industry be able to expand to handle more freight? Or is it just going to handle what it has and leave the rest of it on the highway? Okay. Now, another aspect of productivity is what happens to service? Now, I see a couple people here who understand that in the 1970s, when you took an airline, you never had a middle seat occupied unless you were traveling with somebody. You get on the plane, you have your choice of seats. If you wanted to change at O'Hare and go on a different airline, no problem. You got there early enough to take another flight, no problem. No security problem. You just walk on and fly away. And you paid on your expense account for whatever travel you did. And now with deregulation of the airline industry for 40 years, you have cheaper rates and you have, well, until COVID, you had difficulty sometimes finding an empty seat, finding a seat on the flight. So on the freight side, what happened to service? And I happen to be involved in several different studies of origin destination reliability in the rail industry. And there weren't many of these studies. So in 1975, as part of the freight car utilization program, 3 big companies, Allied Chemical, General Motors, and DuPont, gave us several months of their trip time distributions. So they each served multiple customers from multiple plants. And the average trip time was just about a week. And if you say a week, that means, well, maybe 57% arrive, on time plus or minus a day. Okay, 1988, Burlington Northern was doing a study of service. And this is for rail truck competitive corridors. So it'd be companies like DuPont and General Motors that would have a choice. Miller Brewing Company, have a choice. What did they find? Average trip time is about a day, and 85% were no more than a day early or a half day late. And actually what we found out then was it was very sensible to tell the customer, this is a 7-day trip, even if your car scheduling system said it was going to be 6 days. Because if you tell them 7 days and you're late a day, you're still on time. Very, not quite high tech enough for most of the people that I worked with at MIT, but it was a real insight. Okay, 1991, AAR again did a major study of service. And at this point, we had a 1% sample of all boxcar and covered hopper moves for 1 month. The average time, 9 days. And if you say, well, that's all boxcars, it's the stuff going to out of the way short line railroads, and let's look at the high volume moves. 7.1, 6.8, 7.1, kind of looks the same to me. 49% on time plus or minus a day, 57%, 80. And then with the short line railroads, I did a study a few years later where they looked at what the short line association chose as typical moves. Again, 7 or 8 days, considerable variability. So my conclusion was, despite continuing advances in technology for track equipment control, the service provided to general merchandise freight has been relatively unchanged for more than 30 years. It's hard to say that when my master's thesis 50 years ago was called improving, actually, I think the thesis was called Railroad Unreliability, which I guess was a more apt discussion. When this was published as a research report, my advisor suggested calling it Railroad Reliability. But apparently the unreliability title kind of sticks. Okay, in summary, what do we have? We have a typical chart showing productivity going way up, output going up, and inputs going down. And there are lots of different ways to measure that. However you do it, it's going to come up with a tremendous productivity improvement. And Cliff Winston is an economist. He was down the hall from me for many years. We have discussed and debated the causes of these things for various times. I decided I would quote his statement here, which is one of many. When I walked in to Chris's office today, he said, I understand you don't completely follow the line that deregulation was the savior of the railroads or something to that effect. And I said, no, I don't. This is a typical statement. I'm not picking on Cliff because he probably would like to have a little controversy so he could respond. But the evidence suggests that rail deregulation has accomplished its primary goal of putting the U.S. rail freight industry on a more secure financial footing. Surprisingly, deregulation has also turned out to be a great boon for shippers, as rail carriers have passed on some of their cost savings to them in lower rates and significantly improved trip times and reliability. Now, those who have been listening to what I've been saying might say, really? Rail carriers have passed on some of their cost savings? The chart I showed showed them passing on 80% of their cost savings in terms of lower rates. Significantly improved service times and reliability, not for general freight. And for intermodal and unit trains, the service was always pretty good. So the trip times for a unit train going from the Powder River Basin to Chicago or San Antonio, wherever it's going, is probably not much different today than it was back then. And during the last 20 years, there have been periods of extreme congestion when some of the major mergers were implemented. Right now, in the ports of LA and Long Beach, trying to get everything off the ships and onto the trains, there's periods of increased congestion because the capacity that once existed is now gone. And you might question, well, okay, if deregulation hasn't been the solution, was regulation really the problem it's been made out to be? Now, this is a quote from Donovan Lotan. You probably haven't heard of him because the paper that he was going to write somehow didn't get published because about the time he was writing it and I'm working on it, I was retiring, and it's one of those things that slipped through the cracks as I left my academic career. But he and I discussed this issue, and he decided that he would do this as a thesis. And what he found was that, which I agree with, sort of pushed him a little, is that ICC minimum rate regulation for trucking and railroads had kept those industries alive as you were transitioning from the 19th century to the late 20th century. That the rates, by not falling to marginal cost, allowed the railroads and the truckers to expand and slowly rationalize the way they operated. The trucking companies in 1970 were almost entirely less than truckload. And today, the rail competitive freight is moving in truckload or it's in containers. So it's a much different environment. Okay, the Penn Central bankruptcy, they had problems. They talked about delayed rate increases being a problem. Well, Staggers eliminated those rate increases. It's the downward pressure that was a problem. The passenger rail, that was unrelated to regulation. The labor problems, the railroads eventually worked with the unions. They found a solution where all reduction in the unionized rail workforce was through attrition. The federal government required restrictions on mergers and abandonments that you wouldn't lose your job because of this. And so over a period of 20 or 30 years, the workforce dropped from 700,000 or 800,000 to 200,000 without anybody being fired. I won't say what, maybe there were some people, but the reduction was through natural attrition. People retired, quit. Okay, the ICC, while they were in control, you saw the survival of the railroads and truckers through enormous changes, increased competition, the evolving industrial markets, consolidation of production, high interest rates, inflation, urbanization, and world wars. So it's hard to say that deregulation was as big a problem as it was made out to be, in my opinion. And it's also difficult to say that it's hard to say that regulation was the big problem or that deregulation was the big solution. Many things contributed. The structural change that was facilitated in part by Staggers in the earlier acts, Amtrak and Conrail, big factors. In that first study I did, and I didn't mention this, but it turned out that between 73 and 83, Conrail was actually the most productive railroad. The railroad that was created with the benefit of all kinds of research was headed up by a man named Stanley Crane, who came off Southern Railway. He was the lead of the committee overseeing the freight car utilization program. He was probably the most respected operating engineering research knowledgeable person in the rail industry at that time. He became CEO of Conrail in a time where they really made substantive changes. So we had the change in markets. You get rid of the freight that has to go through 6 or 7 yards, and it's going to look like an improvement in productivity. Technology was here for the William Hay Railroad Engineering Seminar Series. Technology. This university clearly understands and has a very long history in railroad technology, and it was the technology that helped. And not just railroad technology, but I'm seeing everybody here probably there's probably 25 cell phones in this room, and each one of those cell phones is what they were talking about as the operating benefits of positive train control back in 1985. We invest billions in the right-of-way, and the engineer could contact somebody in the home office and find out they had an extra car to pick up. Now it's called a cell phone. So that's the end. These pictures came from last week. My son and I and our families had a place we rented on Pepin Lake, Wisconsin. I don't know if anybody's been there, but if you like vistas across a wide lake, which is actually the Mississippi River, and railroads, there were probably 40 trains a day going by within 20 yards of our cabin. And that, I think most of these pictures were taken when I opened the window and pointed my camera out at the railroad. So you see the BNSF locomotive pulling a double stack train with Schneider Trucking. Schneider and J.B. Hunt were both two of the first and clearly most successful of the truckload carriers, where they were organized to have non-union operations that would carry freight that used to go by railroad. And they're enormously successful, and they immediately, back in the 80s, saw the advantage of using containerized transportation, because they could do the pickup and delivery and then double stack it, and you might see 40 or 50 of the Schneider containers on one of the train, then there'd be another group of, similar number of J.B. Hunt. This is all domestic freight moving on the trains. And the tank train, I showed this because every day looked like there was a round trip of some, I don't know what was in it, but there was something in it, and we're probably all better off having that moving on the railroad rather than going along the highways. And I had to show a picture of Railbox. That was a tremendous innovation in about 1976 or 7, where Trailer Train said, we supply all the flat cars that are used for intermodal. Should we also supply some box cars? And we don't care who loads them. So if Southern Pacific unloads it in San Francisco, they could send it off to Oregon, and somebody up there, the Northern Pacific, could load it there and send it in New England, and then Boston and Maine could load it and send it down to the Louisville and Nashville. So you didn't have all these complex rules, which ended up with empty cars all over the place. And I have to admit that the artwork on the railroad cars is a little bit more pervasive than it was back in the 1970s. That's probably even a bigger change than productivity. I'm not so sure about the quality or the net result, but some of it is quite interesting. So that's it. And I'd be happy to answer any questions or anybody might have.
We do have time for some questions. You just flip on the lights. Now, one comment I'll make about these pictures is that one of our previous speakers this semester, Dick Dawson, was heavily involved with the design of those double stack cars as well as the development.
Oh, yeah? Yeah.
So anyway, we have time for questions. I know the students in 595 have some. Well, we can take some from online, if I can read them. Okay, and I'm not sure which years he's talking about, but this question is there a reason for using the particular years in the comparison over time? Maybe there's a good reason for selecting those years, such as data availability, but it also raises concerns about cherry picking the data.
So the question is, why were these particular years chosen? And in these charts, in many cases, were taken from a study of railroad productivity that was done at MIT, published about 2011. And in there, I went into some length discussing how you compare the years. You have to go from a year that's a peak traffic volume year to another year that's got a peak volume. So you go from peak to peak, or a good year to a good year, or you can look from a recession year to another recession year. So these years were chosen, like one year was 1983. Well, that happened to be when I was doing the study, but it was also a couple of years after the recessions. And 73 was a year, or a couple of years before the recession of 75. So the attempt was made to ensure that there were no obvious disparities in conditions in the years that were chosen. And why were there so many different ones? Well, I wrote a productivity paper around 1983. I updated it a couple of times, about 1988, 1995. And then back in 2010, I updated it again as part of the broader study. So I've tried to show charts where it's distortions because of much different conditions would at least be minimized.
Okay, another question is, can you comment on how freight capacity has been affected by mixed traffic, i.e. mixture of passenger and freight?
Well, okay, how is freight capacity affected by a mixture of passenger and freight? And the answer depends upon how you operate. So going back to the beginning of this period, when you had a lot of passenger trains, when the railroads were relieved of the responsibility for providing passenger trains, it freed up more capacity for railroads. It wasn't that important then because there was so much excess capacity. Over the years, and passenger traffic was declining. Now, in the last 20 years, there's more interest in adding passenger traffic to a freight line. And if you want to operate those passenger trains at 70 miles an hour, and the freight is trying to operate at 45 or 50 miles an hour, you have a problem. And you have a problem if you start out with, if it's a single track line, you're going to get even more problems because that single passenger train going along at 70 miles an hour is going to leave a big empty space behind it because the freight trains can't keep up. So the passenger trains each train eats up more capacity. On the other hand, I was on a rail trip from Toronto to Vancouver in Canada some years ago, right after the Canadian railroads had decided to operate their passenger trains at freight train speeds. So as a large percentage of the people on these passenger trains were not hurrying to a business meeting. They were there to take pictures of the mountains or the fields or whatever, enjoy the experience. So by operating as a freight train, they were just another train in the loop going along at 45 miles per hour. And for the passengers, it meant that someone could come over the loudspeaker and say, attention, there's a nice waterfall coming up on the right. Get your cameras ready, we'll slow down. And so they would slow down to 5 miles an hour and you could see it. Now you go near a city, it's a completely different situation because there are lines that may not be needed anymore for freight if you could rationalize the yards. So you could pull the freight out of the city and leave the lines for commuter rail. So Chicago's a good example for that. the EJ&E was like a big ring road around Chicago, Elgin, Joliet, and Eastern. It's acquired by the Canadian National so that they could route their north-south traffic, come down and around the city rather than going into the city. And that freed up space on some of the radial lines to be used more for commuter rail.
Okay, the questions are pouring in from the internet, so we'll
Okay.
try to hit some of them anyway. So your comments on trip times and reliability hit home. Do you think there'll ever be meaningful change, or is it just structural to how carload is handled? And will PSR move the needle?
CSR.
Precision scheduled railroading, sorry.
The promise of freight car scheduling looked very bright in 1970 when I first started looking at railroads, and it has never worked, in my opinion, because railroads operate 24/7, 365. There's no easy way to catch up. So you have to operate planning on having, I think it's on the order of 30% excess capacity. So if you think you can run 35 trains a day when everything is good, you probably should plan on only 25 or 28, so that when there's a bad snowstorm or a derailment, you could actually recover within a few days. Where was I going? What's the service, is there ever going to be a way to have a reliable railroad? Riley McCarran was one of my best graduate students ever. He came to MIT about 1974, took my freshman seminar on the Northeast Rail Crisis, and it turned out that he had spent much of his youth wandering the rail yards of northern New Jersey and had friends he knew everybody on every train, just like Roger Miller. And he went through a series of, he and I designed the service planning model. He programmed it for a master's thesis. This was how to take a train schedule, use the probability of making connections at the yards, and coming up with a trip time distribution. So if you have something going from boxcar from Champaign to Boston, it might have to go through 3 or 4 yards. And depending on the actual performance might be 3, 4, 5, or 6 days. And we developed a technique for coming up with that distribution. Car scheduling said it will take 4 days, 6 hours, and 30 minutes. And for 40 years now, I've been saying car scheduling does not work. You should look at the actual probabilities, which can be related to train reliability, capacity of the yard, weather, all kinds of things. And you can predict much better. Now, Riley went on and eventually became the CEO of the Wisconsin Central Railroad. And he unfortunately passed away way too early. But before, one of the last things he did, he ended up actually selling the railroad to one of the Canadian roads. But he had Carl Van Dyke and myself in to talk about scheduling passenger travel, not passenger, general freight, scheduling general freight. So if you had a reservation system, the technology for computers is quite sufficient now to say to a customer, okay, we can book you for a Tuesday pickup and it will be available on, 7 days in the afternoon drop off. And take that stuff and relate it to the capacity of the yards that car will go through. And then each yard you can say, well, this yard is a big hump yard where you can handle 2,000 cars a day without a problem, no problem. It's going to get in and go out, no problem. But this yard over here is a service yard, and it tends to get full of empty cars waiting assembly into a grain train, empty grain train, and move it out. So that yard's at capacity. You cannot rely on, so we're going to plan to have it start not on Tuesday, started on Wednesday, and we'll avoid the problem there. And I think that he was onto something there, that it could be worked out. But whether that would be better than full-blown intermodal, I don't know. I don't know. But certainly a better job can be done. And that was an area where Conrail made a lot of improvements in the late 70s, early 80s, where they kind of tried to schedule the local pickup and delivery things and do that on a more regular basis. But it's a hard nut to crack.
We've got several people asking related questions, so I'll just pick one of them. With the anticipated significant decline in coal traffic, will the railroads be able to adapt to the loss of such a significant portion of their present revenue?
I kind of expected that question. I'm not sure what the answer is. I think
3 or 4 of them are asking.
Yeah, coal is clearly, the question is, if coal continues to decline, since we're moving to different sources of fuel for power, electricity, what happens? Well, the coal trains were extremely profitable. It also took a lot of capacity. So there'll be more capacity for, in particular, double stack. That seems to be the primary area. If fuel prices stay high, if diesel fuel stays at $4 per gallon or more, then there could be some greater incursions into the truckload market. My belief is that the railroads will have no trouble surviving, that the coal, UP and BNSF have a lot of coal, but they also have very capable management, and they have the ability to adjust.
Okay, this is another question about precision scheduled railroading. The future of the industry seems to be in pursuit of higher value commodities. PSR appears to be perhaps an impediment to premium service. How do you reconcile these?
I'm not sure. I tried for years promoting more reliable service. The precision railroading, the right car, right train, all of that stuff, the freight car scheduling, there have been different acronyms over the year. And the idea was that precision scheduling would allow you to have better utilization of locomotives and crews and have everything work on time like clockwork, and that would reduce the costs and also allow traffic to move through everywhere more smoothly. But as I said earlier, I don't think you have any hope of that working without having a reservation system where you can deny, well, if you want to get a ticket on a plane and they say it's full, you're being denied service on that plane. There's no equivalent in the railroad. So I think the goal of precision railroading, it's like seeking for something that cannot be obtained, and that same energy devoted to something else of how can we attract more high-valued commodities might be a better way. Remember I said that in the Burlington Northern study of positive train control, they looked at the reliability of service to their major customers. And it came out that the customers thought the service was more reliable than the railroad did. Because the railroad said, well, we have a schedule. They're supposed to be there in 7 days, and it's only making it, let's say, pick a random number. Let's say we're doing that 50% of the time. But the marketing people, perhaps, had learned over the years not to promise too much. Maybe they had told the customer, it's actually 8 days. And so sometimes they were early, they made it there in 7, sometimes they made it in 8. Either way, the customer was happy. Sometimes it was maybe even 8.5 or 9. Well, it didn't happen that often. So it's in attracting the higher volume, the higher valued commodities, if they're, well, there's a marketing part of it. There's how do you portray your service? There's also the equipment. Because where you have specialized equipment, then you have a chance to provide a specialized service that a trucker cannot provide. One example I heard of last week, I think, was have very high, short boxcars designed so you could easily move a forklift in and out and stack things, not to the ceiling, but high enough so that there'd be enough air left in the car so things would stay dry. You know, specialized things that you can't do on a highway might get you some better traffic.
Okay, I think I know part of the answer to this because you're retired, but what current rail trend or issue most keeps you up at night looking into the future? And conversely, what do you consider the greatest rail achievement over the last 40 years?
No rail issues keep me up at night anymore. I've been retired for 10 years. The last time I was up at night for something special was the eclipse of the moon was 2 or 3 weeks ago. That was really nice. So what's the greatest achievement over the last? I think the heavy haul railroading taken as a whole is the greatest achievement. And I had certainly hoped when I was a student that my work on service reliability and then development of the service planning model and P-make analysis, probability of making connections, and all this wonderful way of looking and controlling operations, I really thought that would be what I had done. And, you know, it's led to a lot of things, but mostly it's a reduction in the administrative staff needed to do all the things like developing books, schedule books and whatnot. But the heavy axle load work, you know, this is something that started probably 2 days after the first railroad went into trials back, 1830. Yeah. So the notion that in late 60s, you put in a car that was 263,000 pounds gross vehicle weight rather than 200,000, and it had all kinds of problems. Whereas now, you're routinely operating many more cars with a gross vehicle weight of 286,000 pounds, and the track can handle it. In 1965, 70, a main line would carry 20 million gross tons a year. Now, I still don't really have a great feeling for what does that mean, 20 million? But today, lines routinely carry 100 million gross tons. So I was a math major at one time, and I can divide 100 by 20 and find out that's 5 times as many trains. But I also know that 100 million gross tons, there's a better proportion of freight in that because the equipment is lighter relative to the load. That's an amazing achievement. It's moving more freight, so it means instead of having 4 or 5 lines handling 15 to 25 million gross tons a year, you could have 1 line, do it all, or 2 lines and have some redundancy in the system. And it's required research, it's required academic research, it's required field research, it's required railroads where the managers actually appreciate research and understand the engineering and can integrate engineering, economics, and operations.
All right, well, thank you very much, Carl. I think we'll call it there, but got some other questions here we'll forward to you.
Okay.
And but we'd also like to.
Thank you. Thank you. Oh.
First of all, this mug.
A mug.
And what's special about this mug is
it's empty.
It's empty. Well, if it was full of diesel fuel.
If it was full of diesel fuel.
Let me just read it here for a second. In 1968, and this is appropriate to your talk, in 1968, if this was full of diesel fuel, you could have hauled a ton of freight 27 miles. But today, only half full will haul a ton of freight 27 miles. So They've doubled their fuel efficiency.
Well, very good.
And in
Thank you.
case you're looking for something to fill it up with, we have a special bottle opener. So,
Okay.
so you could fill it with diesel fuel or something maybe more
Something,
potable.
yeah, right.
Yeah.
As I, yeah.
All right.
Well, thank you.
Thank you. Thanks so much. Fantastic.
Thanks.